Question 6. Here is a probability scale. A fair 6-sided dice is thrown. Write down the letter of the arrow that points to the probability the dice lands on. Right, now, probability. If something's impossible, the probability is 0. If something is definite, the probability is 1. And then everything else lies somewhere between. And notice how they've broken this up into 6ths all the way along here. So write down the letter of the arrow that points to the probability the dice lands on the number 5. Well, there's a 1 in 6 chance that it lands on the 5, because it could equally land on the 1, 2, 3, 4 and 6. So 1 out of 6, that's a 6th. So that's represented by B, which is a 6th of the way along. Now part 2, a number greater than 10. Well, with a 6-sided dice, it's impossible to get a number greater than 10. So we've got to have a 0 probability, so the letter A. And then part 3, an even number. Well, we've got 3 even numbers, haven't we? 2, 4 and 6. So it's 3 out of 6, which is the same as 1 out of 2, which is a half, represented by the letter C. Now, Alice says that the probability it will rain tomorrow is 1.2. She cannot be right. Why? Well, as I said earlier on, something that's definite, the probability is 1. You can't get higher than 1. So 1.2 is not possible, because you cannot have a probability greater than 1. Now, Brett has a bag of counters and a box of counters. He's got 1 red, 1 white, 1 blue and 1 yellow counter in the bag, and 1 green and 1 purple counter in the box. Brett takes at random a counter from the bag, and then takes at random a counter from the box. List all the possible combinations. So that's taking 1 out of the bag and 1 out of the box. Now I suggest, just to save you writing loads and loads and loads here, just set yourself up a little code. So a red counter is R, a white counter is W, blue counter B, yellow counter Y, and G and P. And then just literally just every single combination. So starting off with the red one from the bag, that could go with a green or a purple from the box. Then moving on to the white, we could have a white green, white purple. Moving on to the blue, blue green, blue purple. Moving on to the yellow, yellow green, yellow purple. So there are 8 combinations, those listed there. First one being from the bag, second one being from the box. Now write down the probability that Brett takes a red counter and a green counter. So it's this option here, the red and then a green. Well, that's 1 of the 8 possible combinations. It's 1 out of 8, so that's an 8th.